Fine. Well, right now we are going to see how we can calculate the electronic structure of a graphene island using the quantum honeycomb package. So the first thing that you have to do is you open quantum honeycomb by typing in your terminal, and this will open up a window. In this window you have several modules that you can try, but the one that we are interested in right now is this one here. So you click and a new window opens up. In this window you can tune different parameters of your graphene islands. So for example, you can tune the parameters that appear in your Hamiltonian, you can change the geometry of your system, you can add interactions, and you can calculate different properties of your system. So to start with, we will try to calculate the first island, which is put in here by default. So you see here size 3, and we are going to see how our island looks like. This is the island that it's made up by default. And if you see here, you see that these edges are zigzag edges. So you know that you are going to have localized states in there at 0 energy. And if you calculate the eigenvalues of your Hamiltonian, that is what actually happens. You have these states in here located at 0 energy. You can also see that these states are precisely on these edges if you calculate the local density states of your system. So you click here, this will plot the local density states, and if you compare this image with this image, you see that actually the bright parts are the edges. Well, the next thing that we are going to do is we are going to add interactions to our system. So at half filling, if we have interactions, these states in here are going to become magnetic. And to add interactions to your system, the only thing that you have to do is in this part of the program here, you put self-consistency on. And you click afterwards in the ground state button. And now you calculate your eigenvalues, and you see that in comparison with the calculation without interactions, now your eigenvalues are splitted. You can also see that this splitting is spin splitting by coloring the bands according to the projection of the spin over the z-axis. So you select in the bands color of plane S, and you calculate again your eigenvalues, and you see that the eigenvalues that are occupied are the blue ones, whereas the eigenvalues which are unoccupied are the red ones. You can further see what is the magnetic state that your system got by clicking the magnetism button. And the magnetism button opens a window which is pretty similar to the show island, but in this window it also represents the magnetization of your system. So that's all. If you change the parameters in here, you can create many different islands. You can even put vacancies in your island to see the localized states around a vacancy. So this is the end of the first tutorial. Thank you.